Introduction to solar eclipses. A solar eclipse occurs when the moon passes between the Earth and the Sun, temporarily obscuring the Sun's light. This astronomical event provides a dramatic and visually striking phenomenon, as it results in a partial or total blockage of the Sun. Understanding how solar eclipses occur and why they are rare requires knowledge of the alignments and movements of the Earth, Moon, and Sun. The mechanics of a solar eclipse. For a solar eclipse to take place, three celestial bodies must align perfectly: the Sun, the Moon, and the Earth. This alignment happens during a new moon phase, when the Moon is positioned between the Earth and the Sun. The type of solar eclipse, total, partial, or annular, depends on the specific alignment and distances of the three bodies. Types of solar eclipses. Solar eclipses come in three main types. Total solar eclipse occurs when the Moon completely covers the Sun, casting a shadow on the Earth. During a total eclipse, the Sun's corona becomes visible, creating a dramatic display. Partial solar eclipse happens when only a part of the Sun is obscured by the Moon. In this case, the Moon covers a portion of the Sun's disk, and the eclipse is observed as a crescent shape. Annular solar eclipse occurs when the Moon is too far from the Earth to completely cover the Sun, leaving a ring-like appearance of the Sun's surface, known as the Ring of Fire. Orbital dynamics and alignment. The rarity of solar eclipses is primarily due to the specific alignment required. The orbits of the Earth and the Moon are inclined relative to each other. The Moon's orbit around Earth is tilted about 5 degrees compared to Earth's orbit around the Sun. As a result, the Moon does not always align perfectly with the Sun and Earth during each new moon phase. The Saros cycle. Solar eclipses follow a pattern known as the Saros cycle, which is approximately 18 years, 11 days, and 8 hours long. After this period, the Sun, Moon, and Earth return to nearly the same relative positions, making a similar eclipse occur. This cycle helps predict when and where eclipses will occur, but due to the slight shifts in the orbit, exact alignments are rare. Eclipse paths and visibility. Even when a solar eclipse occurs, its visibility is limited to specific regions on Earth. The path of totality, where a total eclipse is visible, is relatively narrow, often only about 100 miles wide. Observers outside this path may see a partial eclipse instead. The geographic location and the width of the eclipse path contribute to the infrequency of witnessing a total solar eclipse from any given location. Impact of Earth's rotation. The Earth's rotation also affects the duration and visibility of a solar eclipse. As the Earth rotates, the shadow cast by the Moon moves across the surface, making the total phase of an eclipse last only a few minutes at any given location. This brief duration further limits the opportunity for observing a total solar eclipse from a specific area. Eclipse visibility and frequency. While solar eclipses are not particularly rare on a global scale, any given location may experience a total solar eclipse only once every 375 years, on average. Partial eclipses are more common, but they still follow specific patterns and cycles that affect their frequency and visibility. Historical and cultural significance. Throughout history, solar eclipses have captivated human interest and influenced cultures. They have been seen as omens, used for scientific research, and celebrated as extraordinary natural events. Their rarity and dramatic appearance contribute to their ongoing fascination and significance in various cultures. Conclusion. Solar eclipses occur due to the precise alignment of the Earth, Moon, and Sun, with their rarity attributed to the specific orbital dynamics and visibility constraints. Understanding the mechanics and cycles of solar eclipses enhances our appreciation of these rare and awe-inspiring astronomical events, highlighting the intricate relationships between celestial bodies.